Welcome to May 2021 DevOps for Defense. Thank you guys for coming out. Today we're going to take a little bit of time and we're going to talk about containerization. So next, oh come on, next. Let me see why my next button's not working. I might, would you mind? That'd be a lot easier. It wasn't working. There we go. So let's just kind of start over because I got to put this on the YouTube. If you don't know, we do have a YouTube channel. We record all of our stuff. I edit it up like over the weekend. So if you want to go back and see what we've done for like the last year and a half, you can see Red Hat's presentation. You can see John Willis, co-author of the DevOps Handbook presentation. You can see GitHub's presentation. You can see Hans Docker came. He's a CEO of Gradle and did a presentation for us here. It was amazing. So we had a lot of cool stuff there. But yeah, there's a ton of stuff. So we are recorded on YouTube. We'll publish it to YouTube. But that's what we're doing. That's what's going on. I don't need to hold the clicker. So anyway, welcome to the May 2021 DevOps for Defense. Number one, welcome back. It's been just over a year. Our last live meetup was March of 2020, and we've been kind of on and off and virtual since then, which has been, I'm glad we've been able to do that. We got a lot of participation from across the country, Virginia, Colorado, Nebraska, Arizona, California. We've really gotten some great participation in the virtual session, but it's so nice to be back with real people and face-to-face with a nice beer in my hand. So that's awesome. And of course, thanks to our sponsor, Tech Systems, for bringing in some pizzas to help us get restarted here. And thanks to Rocket Republic for continuing to host us. Very, very generous of them to do that. And we are going to we aren't giving up on the virtual stuff. So there is a Zoom going on as kind of a hybrid thing. We'll see if that works with the in-person and the virtual at the same time. I don't know, but welcome back. I'm super excited. Next chart. So as always, we start with our code of conduct. This is obviously an unclassified setting, so no dirty words. We also want to make sure we treat each other with respect and professionalism. Please don't talk about your secret sauce. I don't want to know. Nobody else wants to know, but please do talk about your experiences, your frustrations, what you need, how others can help you, and please reach out and help others. Share your thoughts, and make sure you take the opportunity to learn from some of the super smart people around you today. If you're attending virtually, please mute yourself while others are speaking. But if you have a question, I don't know if the audio works in this hybrid setting. You can try it, but I can't promise anything. So next chart. So containerization in the defense world. Why are we talking about containerization? We kind of hit this like a little over 2 years ago, maybe right at 2 years ago. And it's been interesting to see how this is evolving. So what's going on? Well, number one, just recognize the commercial world is like super far out in front. Like this is just normal for them. For us, it's kind of a different space where the defense world is just getting their heads around what containerization is. And we see strong evidence of that in the DevSecOps Reference Design, which fundamentally requires you to containerize your software. It requires you to run things in a Kubernetes environment, which is very new to the defense world. I say new, but I also know that that thing was published almost 2 years ago. And it kind of blows your mind how time has passed. We're now seeing, I mean, there's contracts on the street right now that literally have shall statements that you must containerize all your stuff. It's a contractual requirement. And so how are we going to do that in a world that doesn't really understand containers, that's pretty far behind the commercial world, and is just now getting their heads around what this 2-year-old document really means to us as system builders, developers, maintainers, and operators? And most importantly, how on earth are security professionals going to really get their heads around all this? That seems to be a really significant obstacle in our world. What does it mean to get an authority to operate of what's fundamentally web-based technology, right? When everything's looking cloud, it makes our security professionals pretty uncomfortable. So we need to work to help them understand what these things are. I did want to point out there's a couple of key, kind of popular technologies here. I'm not advocating any one or the other, but you're probably all familiar with Docker, right? It's kind of the thing that got containerization super popular. Another one is a Red Hat product called Podman. They fundamentally do the same thing, container runtime. They do things in slightly different ways, but interestingly, if you find yourself in an environment where you can't use Docker, you can install Podman, and you can actually create an alias to Podman and name it Docker, and it works. So that's interesting, just FYI. Next. So there's tons of really good resources online. If you aren't, super familiar, there's some great kind of introductory material. These IBM guys have a great talk. It just gives you the overview of what containerization is and how that works. The link here will be published in the charts on the website, so you can get to these pretty easily. But there's some great stuff there, and if you're deep into it, you kind of know what it is, but you want to get to the real deep nuts and bolts of how all this stuff works. I would recommend Liz Rice's talk called Containers from Scratch. In like a 45-minute conference presentation, she writes a container runtime in Go live on the stage. And if you ever wondered, what are the nuts and bolts? How does this work? What does isolation mean? What is process isolation? How are resources isolated? All that stuff. It's incredible to watch it go. You can see it live happening, and you can understand the intricate details of how the kernel is manipulated to allow these things to happen, to give you the protections and the additional security of containers. Next. So what are containers? Fundamentally, containers is a really cool way to package, deliver, and distribute your software, right? So you need to be able to get this stuff into a target environment. You want to be able to understand and control what that environment is. You need to establish and maintain configuration management of that so that you can predictably run your software. Containers let you package not only your piece of executable code, but all the dependencies that live around it. So it's really neat. The next chart. But what it's not is a virtual machine. And this is where, especially our security people, they've now gotten very comfortable with virtual machines. They know how to deal with it. And this container thing looks and feels a lot like a virtual machine to them, but it's not. And helping them get over that hurdle to understand why it's important, how it works, and how you deal with and manage it is super important. I'm going to show you a quick demo here at the end that hopefully achieves the objective of proving to you that containers are not virtual machines. Next. So how's a container work, or what is it? Number one, first and foremost, a container is nothing more than a process. It's just an executable packaged with its execution environment. It provides you isolation by using kernel namespaces. It allows you to do resource sharing with kernel C groups, and it allows for encapsulation using pivot root. So it uses these kernel mechanisms to give you strict control of the execution context and separates your application from anything else running on a computer, on the host. If you're running your application in a container, it can't access that host unless you take special steps to make that possible. So from a security perspective, this should be phenomenal, right? I can run my executable. It lives in its own little world, and it's locked in that little world. So it can't get to anything else running on that host, which is great. It's also great for an application developer because you don't have to worry about other things running on that host, jacking up your stuff. Next. There's this big discussion about container orchestration. If you have read the DevSecOps Reference Design, it only requires by name one thing, and it's Kubernetes. So what's Kubernetes? It's a container orchestrator built by Google. There are a lot of packaging and distributions of that. Some that you're probably familiar with is Rancher. That's a pretty common one. Rancher Federal has recently published the RKE2, which is cool because it complies with things like SE Linux controls, and they've got a draft STIG. It's about to be published by DISA, so that's pretty cool in our world. Red Hat OpenShift, this is one that's very popular, and I would encourage you, if you're not familiar with OpenShift, you can go back to our, November of 2019. And you can see a Red Hat presentation on our YouTube channel. Really cool stuff, good guys there. Other solutions that, so those two are kind of ready for on-prem, like you get to hug your servers and set all it up and, you know, name them and all that stuff. If you're not into loving your server and you're willing to use somebody else's server, then you can go to services like Amazon and Azure. These both have not only, now they have IL4, which will allow you to do things like FOUO and CUI processing, but they also have certified IL6 environments. IL6 will allow you to do classified processing. And so you don't get the full like commercial suite of capability, but you do get things like, for an Amazon instance, you can get EC2, you can get S3 buckets, right? You can get all these great services that all of a sudden you don't have to worry about, right? And that's super helpful because it lets you spin things up, spin things down, establish test environments, and even operate things. Oh, so next. So I wanted to take a minute. I'm going to walk out of the camera, which I've already been doing a lot, and give you a quick demo of what some of this stuff is. Put some thoughts in your mind, maybe give you some stuff to talk about a little bit later. I have an acceptance criteria established for my demo. I'm looking for feedback. Let me know if I hit the mark or not. Two things. I want to make sure that I demonstrate containers are not virtual machines. And I hope that I hope you walk away from this going, oh yeah, totally obvious. Containers are not virtual machines. And then I want to demonstrate why people get confused about that. Why would someone think that this thing that's obviously not a virtual machine might be a virtual machine? So I'm looking for a little bit of feedback on whether or not we hit the mark on that. So let me just dive in for a second. I'm going to pull up VS Code. Oh, I'm going to try to pull up VS Code. Oh, I'm ruined it. My surprise is ruined. So I guess while this is going, let's hit AC2 before we do anything. So what am I doing? I'm actually using something called Gitpod. Is anybody familiar with Gitpod? Ever heard of it? No? Just Val. All right. So what is Gitpod? You guys familiar with VS Code? Eclipse, the Eclipse project? Familiar with that at all? So Eclipse Theia is a packaged version of VS Code managed by the Eclipse Foundation, but it's built to run in a fully containerized Kubernetes environment. So how do I get my IDE up in this specific demo? I go to my GitHub repo and I click the button and it launches in my web browser. So now I have a fully functional environment for doing development in my browser that's 100% container based. And I even have things like terminals. So how would someone, how could somebody get confused that that my container is really a virtual machine? I can kind of do everything. I can treat it like a computer if the containers have the right stuff in it, right? I can, what I've got here is a very, very simple application called Hello World. I think we all know this one, right? Just simple C++. I can do things like, go to my cheat sheet. I can do things like compile in my terminal. Whoops. What I'm doing is I'm just copying from my workflow. So I can do things like compile my application, right? That's the sort of thing that you can do in a virtual machine, obviously. But it looks and feels just like that, although it's not. So what have I done? I've just compiled. I've just compiled and run Hello World. I can do things. I'll prove to you that I'm actually doing it. Hello. DevOps for Defense. So we'll save that. I'll recompile. And I'll execute it. And you can see we've got changes in the message. So that's what we're doing. We've got a complete environment, looks and feels just like my local computer, but fully containerized. So you can, hopefully AC2 is complete. You can see how someone would look at this containerized stuff and think, oh, that looks and feels and tastes just like a virtual machine to me. And if it's configured to do so, yeah, it does look and feel and taste just like that. But I can also, you'll notice when I compiled with the static flag. So why is that important? What does static do? Static takes all those shared libraries that you would normally rely on being provided by your execution environment, and it compiles them into the executable so that it can run completely standalone with no local dependencies, right? And if I go to, and I do my Docker build, what I'm doing, and I'll show you how it works here in a second. So what I'm doing is I've just taken the definition of my container, which is this Docker file, and I've started from scratch. Scratch is a keyword that means absolutely nothing in the container, right? Blank slate. I've copied in my application, and I've said what the entrance criteria for that application is, right? What's the executable that I want to run? I told you that a container was really a process. So I'm defining the process that I'm interested in that CMD command. So now I have this container. What on earth am I going to do with it? Well, I can run it. So it's got a name and a tag. So I'm going to copy that. I'm going to run it. And I got the exact same output from a single file in a single container execution context. There is no operating system. There is no extra files. There are no shared libraries, just that file. So I hope that you could understand that it can run applications, but it's really the host's kernel that's running the application. It's not anything in the container that you didn't explicitly put there. So hopefully that convinces you. We could go in and do forensics and tear the thing apart. That'd take a lot of time. But hopefully that convinces you that a container really and truly is just an application. It's just something that isolates a given process that as you specify it and lets you execute it in a controlled context, sometimes with nothing else, right? So anyway, that's the demo. I hope I achieved my acceptance criteria. You guys can tell me if I missed the boat, but that's what I hope that demo does. Everything there is published on open source. We'll get something up on the blog with links to it. If you want to try it yourself, you can absolutely do that. And I'll put some context in there for how to launch it in your own Gitpod environment in your own browser. You can try it for yourself. So that's our talk on containers. Very high level overview, but I hope everybody got something valuable out of it. We're going to call it a day for the presentation part. We've got some lean coffee tables set up around the room here. I don't know how many people we had dial in for the virtual session, but if Scott dialed in, he's going to host a agile.coffee session for anyone who would like to participate. It's just a lean coffee set up for online, no logins, no nothing. It's really cool if you ever want to try it out yourself. But we'll do that. For those in the room, number one, it's awesome to see people again. So thank you guys so much for coming out. We'll have some pizza. We've got some lean coffee tables if you guys want to get together and do a lean coffee. If you just want to socialize because you haven't seen people in real life for so long, that's cool too. But that's we're going to call it done for today. If you want to do a lean coffee, come join the table, and that's it. Thank you for coming out.